Welcome to the deep dive. Ever stop to really, look at a pile of sand?
Probably not something most people think about.
Exactly. But today, we're venturing into the, surprisingly complex world of sand dunes.
It really is fascinating stuff.
You've got a great collection of articles and research here, everything from fun fact lists to deep dives on managing them, protecting them, even a guide on where to see the really spectacular ones.
Yeah, quite a mix.
Our mission really is to uncover some hidden wonders and explain why these sandy shapes are, much more important than they might look.
That's right. We'll be looking at sources like 15 fun facts about sand dunes. That's a good starting point for the cool bits.
Yeah, get us warmed up.
And then digging into things like 18 sand dune management and restoration to get a handle on their environmental significance.
Right.
We'll also touch on Wikipedia's dune entry, pretty comprehensive that one, and a policy brief. Sand dunes plus that travel piece. Where can I see spectacular sand dunes around the world?
So for you listening, the learner, think of this as your express ticket to dune knowledge, packed with aha moments, hopefully, but without getting totally bogged down.
We'll keep it moving.
Okay, so let's start right at the beginning. What exactly is a sand dune? And how does wind turn, loose sand into these hills we recognize?
Well, at its heart, a sand dune is really just a hill of sand. Simple as that. But it's built by the wind.
Okay.
It's a process scientists call aeolian. Think of the wind as a sculptor, basically, constantly picking up sand, carrying it, dropping it off somewhere else.
So it needs wind, obviously.
Absolutely. And the magic kind of starts when that wind carrying the sand hits some kind of obstacle. Could be anything, really. A clump of grass, a bush, even just a little rise in the ground.
And that makes the wind drop the sand.
Sort of, yeah. It's more that the obstacle slows the wind down. Right there. And when the wind loses speed, it just can't carry those sand grains anymore. So plop, they get deposited behind the obstacle.
Makes sense.
And interestingly, the sources point out something cool. Sand grains hitting other sand grains. They're actually more likely to stick than sand hitting, say, a smooth rock.
Really? Like attracts, even with sand?
Kind of. It creates this sort of snowball effect. The more sand piles up, the better that spot becomes at trapping even more sand.
Oh.
And this movement, this bouncing and hopping of sand grains, the wind pushes along. That's called saltation.
Saltation. Okay.
So yeah, imagine trying to skip a stone across water. The sand grains do something a bit like that across the ground.
Okay, that visual helps. Skipping stones, saltation. And the sand sticking to sand thing, that's neat. Now, the classic dune shape, I always picture one side that's kind of long and gentle and the other's really steep. Is that how it usually works?
That's a very common, accurate picture, yeah. The long, gentle slope that faces into the wind usually. It's called the Stoss side.
Stoss side, right.
The wind pushes the sand up this slope. Some grains just roll. That's called creep. Others do that bouncing thing we talked about, the saltation.
Okay, creep and saltation of the gentle side.
Exactly. Then, once the sand gets to the very top, the crest, there's nothing holding it up on the other side, so it tends to just slide down. And that side, the downwind side, is the leeward side. It's shorter, much steeper. That's the slip face.
The slip face, like a sandy slide.
Precisely. And the low bit, the sort of valley between two dunes, that's often called a slack, or sometimes an interdunal swale.
Okay, got it. Stoss windward, gentle, slip face leeward, steep slide, slack the valley in between. Cool. Now, dunes obviously aren't all the same size. You see tiny ripples, but then these massive sandy mountains too. Are there official categories?
There are. Scientists classify them, yeah. Ripples are the tiny ones, less than maybe an inch high.
Okay.
Then you get what we usually just call dunes. Bigger than a few inches. But then there's this other category called dries.
Dries.
D-R-A-A-S. These things are gigantic. Seriously. They can be kilometers long, hundreds of meters high.
Woo! Hundreds of meters.
Yeah. And what's really wild is sometimes you find regular dunes sitting right on top of these huge draws, like a whole dune landscape on the back of a sand monster.
That's incredible. Kilometers long. Wow. Now, the sand itself, what's it made of? Is it all just, beach sand? Quartz?
Quartz is super common, yeah. That's your typical silica sand. But dunes can actually be made of lots of different things. Depends what's around locally.
Like what?
Well, the sources mention calcium carbonate. You'd find that near coasts with lots of shells, coral maybe.
Okay.
Surprisingly, dunes can even be made of snow in really cold places. Or gypsum. That's what makes those amazing white sand dunes we should talk about later.
White sand's from gypsum, not just bleached sand. Cool.
Yeah. Or other minerals, too. The main thing is the particle size, generally between, let's see, 0.06 and 0.5 millimeters. That's the sand size range.
Gotcha. So these aren't just static piles then. I read somewhere they actually, move.
Oh, absolutely. That's one of the most amazing things about them. They're dynamic, constantly shifting, changing shape. The wind never stops working on them.
So they migrate across the landscape.
They do. And even though they look maybe barren, these dune landscapes are actually home to some really cool, really resilient desert species.
Like what kind of animals?
Well, think sand gazelles, perfectly built for moving on loose sand vipers that just blend right in, fringe-toed lizards. They have these special scales on their feet so they can almost swim through the sand.
Swim through sand.
Yeah.
Wild.
Yeah. Even sidewinder snakes,
Yeah.
They develop that unique sideways shuffle, partly to handle the shifting dunes. They have amazing adaptations for heat, storing water.
Incredible how life adapts. And you mentioned those huge heights earlier, 500 meters.
Yeah.
That's taller than the Eiffel Tower.
It is, seriously. The sources stress that some dunes reach these just staggering heights, like sandy skyscrapers. You find them in deserts all over the world. Standing at the bottom of one must be humbling. Really shows you the power of nature.
Absolutely. And they can move pretty fast, right?
Yeah.
Like you could visit one year and it's actually shifted noticeably by the next.
Some types move surprisingly quickly, yes. Those crescent-shaped ones. Barchan dunes, they're called. They're known for being speedy.
Barchans.
Yeah. One source mentions a group in China moving over 100 meters in just 1 year, back in the 50s. And we've seen similar speeds elsewhere.
100 meters a year.
And the really big ones, the largest crescentic dunes, they can be enormous, over 3 kilometers wide. You find those massive ones in China's Taklamakan Desert.
3 kilometers wide. Moving 100 meters a year. That scale is just mind-bending.
What about those steep slip faces again? There must be some interesting physics going on there.
You bet. That's where the sand piles up, right? Pushed over the crest, it builds and builds until it gets too steep, basically unstable. Then gravity just takes over. You get these little flows, cascades of sand sliding down, like mini sand avalanches.
Little sand avalanches, I like that.
It's this constant cycle. Sand pushed up the gentle stoss side, tumbles down the steep slick face, and that's what drives the whole dune's movement forward.
And climbing up that steep side. Sounds tough. Oh, it is. Anyone who's tried knows it's incredibly tiring. Like walking on a sandy treadmill that keeps collapsing. Some studies say the energy you burn is like doing a really intense workout.
I believe it. Okay, so moving, towering, sometimes treacherous sand mountains. But they make sounds too. I saw something about singing sands. That sounds completely made up.
Doesn't it? But it's real. And pretty eerie. Under just the right conditions, very specific conditions, some dunes can actually produce sounds. Hums, whistles, sometimes even these sort of wailing noises.
What is that?
It's thought to be friction. The sand grains rubbing against each other as they move or slide down the slip face. The exact size, shape, moisture content of the sand, even the atmosphere. It all has to be just right.
Wow. Imagine hearing that in the middle of a silent desert.
Exactly. It must be quite an experience. Almost musical, but uncanny.
Truly wild. Okay, and then there were the white dunes you mentioned. Not just sun-bleached sand, you said.
Not at all. Places like White Sands National Park in New Mexico, those dunes are often pure gypsum crystals.
Gypsum?
Yeah, these crystals are kind of translucent, which gives the sand that brilliant white look. And here's a neat detail. Gypsum reflects sunlight really well, so that white sand stays surprisingly cool, even when the sun's blazing. Much nicer to walk on barefoot than dark sand.
That's a great fact. Cool sand. Okay, singing, white, glowing sand, bioluminescence. In a dune.
Okay, this one sounds even more improbable, I know, but it's also real, though usually in coastal dunes, not so much dry deserts.
Coastal dunes, right.
Yeah. Sometimes moving the sand, like walking on it at night, can disturb tiny microscopic organisms called dinoflagellates.
Dino what?
Dinoflagellates. They're a type of algae, and they're bioluminescent. They live in the sand or maybe the shallow water right there. When you disturb them, they give off this amazing blue-green light.
So the sand literally glows.
The sand appears to glow, yeah. Because these millions of tiny organisms are lighting up. You can see it in places like the Maldives, parts of the California coast sometimes.
Incredible. Singing, white, glowing. Is there anything else? Oh, wait. Booming dunes with that thunder sand.
Almost. Another sound thing. Booming dunes. Again, very specific conditions needed. Moisture, grain size, shape, all seem to matter. But when the sand is disturbed, maybe by wind or someone walking on it or a big slide down the slip face, it can produce this really low-frequency booming sound, like a deep hum or a roar that seems to come from inside the dune itself.
Whoa.
Scientists are still figuring out the exact physics, but yeah, booming dunes adds another layer of mystery, doesn't it?
It really does. This is all way more interesting than I expected. But beyond being fascinating and sometimes noisy, surely they have some important, purpose.
Oh, absolutely. Sand dunes play really crucial ecological roles, and protective ones too, especially near coasts.
Protective how?
Well, think about big storms, big waves hitting the shore. Dunes act as natural barriers.
Ah, like a natural seawall.
Exactly. When those huge waves crash, the loose sand of the dunes absorbs and dissipates so much of that energy. It massively reduces erosion on the land behind them, and it lessens inland flooding.
That makes perfect sense.
And they're dynamic. Wind moves sand around, so they're often kind of self-sustaining, self-repairing barriers. Wind brings back sand that storms might wash away.
Better than a concrete wall, maybe?
Often, yes. More adaptable in the long run. Plus, they do other vital things, like protecting groundwater.
How do they do that?
Coastal dunes help stop saltwater from seeping into the freshwater aquifers underground. That's absolutely essential, both for the coastal ecosystems and for people who rely on that fresh water.
Wow, I never would have thought of that. Preventing saltwater intrusion.
Yeah.
Huge. What else?
Well, sometimes in deserts, you get oases forming right at the base of dunes.
Really?
Yeah, the dunes can create these natural low spots where groundwater collects. Suddenly, you've got this lush little habitat in the middle of nowhere.
Amazing.
And of course, the dunes themselves, even the dry ones, are unique habitats. They support specialized plants and animals that have evolved incredible ways to survive the heat, the lack of water, the shifting sand.
Like those lizards and snakes you mentioned.
Exactly. And specific plants, too, like beach morning glory, sand spinifex. You find things like the fan-throated lizard, sand boas. Even sea turtles use some dunes for nesting.
So they're little biodiversity hotspots in their own way.
Definitely. And in coastal systems, those low areas between dunes, the slacks or swales, they often have a higher water table, so you get distinct wetland plant communities there, sometimes even really rare species that only live in those specific damp spots between the dry dunes.
It's a whole complex ecosystem.
Okay.
Clearly vital ecologically. What about us, humans?
Yeah.
How have we interacted with dunes over time?
Oh, our relationship with dunes goes way back and is pretty significant. Think about nomadic peoples in deserts. Dunes offered pathways, maybe resources, shaping their whole lifestyle.
Right.
And historically, dunes can preserve things incredibly well. The layers of sand act like time capsules. We find ancient fossils, artifacts buried in dunes that tell us about Earth's history. Some amazing finds in the Sahara, for example.
Like sandy archaeology.
Kind of, yeah. And on a totally different note, think movies. How many times have you seen epic desert scenes? Dunes make incredible natural movie sets.
Oh, yeah. Lawrence of Arabia,
Yeah,
Star Wars.
Exactly. Those iconic backdrops. They wouldn't be the same without those sweeping dunes.
True. And I've seen videos of dune racing, too. It looks intense.
It is. Dune bashing, dune racing. It's a whole motorsport. Thrilling stuff, using those slopes for adrenaline.
High-octane fun.
And then there are really deep traditional livelihoods tied to dunes. In places like Tamil Nadu in India, the sources mention palmyra trees growing on dunes.
Palmyra trees.
Yeah, they're super important locally. People extract jaggery, a type of sugar from them, use the leaves for thatching roofs, make crafts. It's deeply woven into their economy and culture.
Wow.
And fishing communities, too. They often use the beaches and the first line of dunes, the foredunes for drying nets, launching boats. And they often build their villages on dunes, the higher ones, for safety from storms and a better view of the sea.
So, yeah. From survival to culture to entertainment, dunes are really part of the human story. But all this interaction, it must have downsides. Are we damaging these ecosystems?
Unfortunately, yes. Dune ecosystems are definitely facing some serious threats. Big ones.
Like what?
Well, sand mining is a huge issue in some places. Just digging up the sand on a massive scale for construction materials or minerals. It literally removes the dune and totally changes the landscape.
Takes away the raw material.
Exactly. Then there's coastal engineering, building seawalls, groins. Those hard structures, they mess up the natural movement of sand along the coast. They can end up starving dunes of sand, making erosion worse elsewhere.
Trying to fix one problem causes another.
Often, yeah. And just building things on or near dunes, houses, hotels, roads, it directly destroys the habitat, increases foot traffic, and stops the dunes from being able to naturally move or retreat, which they sometimes need to do.
And invasive species. I bet they're a problem here, too.
Okay.
Big time. Plants like ice plant, Carpobrodus, edulis, or European beach grass.
Right.
Sometimes they were even planted on purpose decades ago to try and stabilize dunes.
But that backfired.
Often, yes.
Yeah.
They're aggressive. They outcompete the native dune plants that are adapted to that specific environment. So you lose biodiversity, and the whole structure of the dune can change, sometimes becoming less stable in the long run. Then there's pollution. Oil spills are devastating, obviously, but also just plastic trash accumulating. It harms wildlife, smothers plants, and even just recreation. Too many people walking, driving, playing on sensitive dunes can cause massive erosion and damage over time. Oh, and planting non-native trees, like casuarina, sometimes done for timber or stabilization, can actually harm native plants, lower the water table, and reduce biodiversity, too.
It sounds like a lot of pressures, many unintentional maybe, but still damaging these systems we're only just starting to appreciate fully. Are people trying to protect and restore them? Thankfully, yes. There's definitely a growing awareness of how important dunes are, especially for coastal defense. The 2004 Indian Ocean tsunami was a huge wake-up call for many. They saw how well-preserved dune systems offered real protection.
So that spurred some action.
It did. Some places have brought in laws to protect dunes, like India's coastal regulation zone rules, though enforcing them and keeping them strong can be a challenge.
Bureaucracy and development pressure.
Exactly. But restoration projects are happening too. Like Reduna in Portugal, they're using native plants and special fences to help rebuild damaged dunes and bring back wildlife.
That's good news.
And there's also interest in reviving traditional local methods that worked well, like using palmyra leaves woven together to trap sand and help dunes grow naturally, which they're doing, again, in parts of India.
Learning from the past.
Yeah. But overall, there's a clear need for, well, more research, better monitoring to see what's happening, and getting local communities really involved in protecting and restoring their dunes.
It's encouraging that things are moving in the right direction, even if there's more to do. Now, if someone listening is inspired and wants to see some of these amazing places, where should they go? What are the most spectacular dune spots?
Oh, there are some truly mind-blowing dune landscapes out there. Lençóis Maranhenses National Park in Brazil. It's famous for these brilliant white dunes, but between them, seasonally, you get these incredible turquoise freshwater lagoons. Just stunning.
White dunes and blue lagoons, wow.
Then there's the dune of Pilat in France. It's the tallest dune in Europe, right on the coast. Incredible views.
Okay.
In the U.S., Great Sand Dunes National Park in Colorado, tallest dunes in North America, and they're right up against mountains. Really dramatic contrast.
Sounds amazing.
Namibia's Sossusvlei. That's where you get those iconic fiery orange, really tall dunes, like Big Daddy, one of the most famous ones.
The classic desert look.
Totally. Alice Vars Lake in Saudi Arabia, it's this yellow lake oasis surrounded by impressive dunes. Vietnam has the white and red sand dunes near Mine, very picturesque.
Lots of variety.
Definitely. Kazakhstan has the Altan Emel National Park, home to those singing sand dunes we talked about. Australia has the Mungathuri, or Simpson Desert. That's the world's largest dune desert by area, just vast parallel dunes.
The biggest dune desert.
Yeah. China's Mingshan also has singing dunes, plus a beautiful little oasis called Crescent Lake right next to them. And Oman's Wahiba Sands gives you that quintessential, huge, golden desert experience.
That's quite a list. Definitely some travel inspiration there. And did you mention dunes on other planets?
Oh, yeah, that's right. Sand dunes aren't just an Earth thing. We've seen amazing pictures of dunes on Mars from the rovers.
Dunes on Mars.
And even on Titan, Saturn's biggest moon. Though, get this, the dunes on Titan probably aren't made of silicate sand like ours. Scientists think they're made of hydrocarbon particles, frozen solid because it's so incredibly cold out there.
Hydrocarbon dunes on Titan. Okay, that just blows my mind. That really expands the whole idea of what a sand dune can be.
Doesn't it?
Well, this deep dive has completely changed how I see what I used to think were just, simple piles of sand. They're clearly so much more complex, so important.
Absolutely. So just to quickly recap the big picture, we've seen dunes are dynamic, always changing. They come in incredible varieties of size, what they're made of, even the sounds they make.
Right. Singing, booming.
Yeah. And ecologically, they're vital, protecting coasts, safeguarding water, providing unique homes for specialized life. Plus, they have these deep cultural and historical links with people all over the world.
So for you listening, maybe the next time you see what looks like just an ordinary pile of sand, take a second look. Consider it in this new light.
Yeah.
And maybe think, what other mundane things in nature might be holding equally fascinating secrets? Perhaps check out the local geography near you, especially if you're near a coast or desert. See if you can spot some of the dune types we talked about. You might be amazed at the intricate world hidden in those sandy shapes. Thanks for joining us on this deep dive.